Hello, this is a presentation on round-robin scheduling algorithm for the internal assessment of operating systems by KARUNESH. So what is round-robin scheduling? The name of this algorithm comes from the round-robin principle, where each person gets an equal share of something in turns. That is, there is a circular arrangement in the form of queue where each and every task or person gets equal amount of time for it to perform the task. It is the oldest, simplest scheduling algorithm which is used mostly for multitasking. It is used for multitasking because it is the most efficient way for performing of multiple tasks altogether. In round-robin scheduling, each ready task runs turn by turn only in a cyclic queue for a limited time slice or time quantum. So what happens here is all the tasks are assigned in a circular manner so that every task runs turn by turn for a limited amount of time, yes, 2 microseconds. This algorithm also offers starvation-free execution of processes. So what starvation is when a low priority program is requesting for a system resource, but it isn't able to be executed because a higher priority program is utilizing that resource. So that is starvation. Now, what are the characteristics of round-robin scheduling? Round-robin is a preemptive algorithm. So now what is preemptive algorithm? It is when a process switches from running state to steady state or waiting state to ready state. Now, the CPU is shifted to the next process after fixed interval time, which is called time quantum or time slice. So this is the same that I was talking about earlier, that the fixed interval time that is given for each of the tasks to be performed. The process that is preempted is added to the end of the queue. Preempted, that is the process that is still going to take place again and is still in the queue. Round robin is a hybrid model which is clock driven. From here we understand that it works on time principles. Time slice should be minimum, which is assigned for a specific task that needs to be processed. However, it may differ from OS to OS. Now, why the time slice should be minimum? Because if the time slice is greater, it may be possible that starvation may occur. So, if the time slice is minimum, everyone will get less time, but many a times. It is a real-time algorithm which responds to the event within a specific time limit. Now, specific time limit is everyone is given equal and constant time to perform its task, and then it may be repeated. So, it works on real-time approach. Round robin is one of the oldest, fairest, and easiest algorithm. It is used from a long time, widely used scheduling method in traditional operating systems. So it is used widely and is one of those algorithms that work on preemptive scheduling. Like some of its examples are short remaining time first, SJF, and others. Now, advantages of round robin scheduling. It doesn't face the issue of starvation of conveyor effect. I've explained this earlier. All the jobs get a fair allocation of CPU. As I said, everyone gets an equal space and equal time to perform it. It deals with all processes without any priority. Yes, everyone is given equal time slice. If you know the total number of processes on the run queue, then you can also assume the worst case response time for the same process. That if there are many processes, then the repetition and arrangement may be different or complex too. The scheduling method does not depend upon burst time. That's why it is easily implementable on the system. It does not depend on the burst time. It gives everyone equal time slice and it gets divided so that the working is done. I'll explain this later in the slide. Once a process is executed for a specific task, specific set of the period, the process is preempted and another process executes for that given time period. Just like I explained, once the time slice is over, it goes into the residue or at the end of queue and the next task is performed. It allows operating system to use the context switching method to save states of preempted processes. It allows the operating system to use the method of context switching so that the preempted processes states are being saved for the efficiency. It gives the best performance in terms of average response time since equality is here for all the tasks. So there is no priority based things. Disadvantages of round robin scheduling. If slicing time of OS is very low, the processor output will be reduced. Simply, if the processing time is very low, it will not give any process an ample amount of time so that it can be performed. So the processor output will naturally be reduced. This method spends more time on context switching. Context switch is the process of storing the state of a process or thread. That is, if a process is going on and then you store its current state, and if it can be restored and its execution can be resumed at a later point, then it is called context switching. This method spends more time on context switching, as I've already explained. Its performance heavily depends on time quantum. Time quantum, that how much time is given to all the processes to take place. Priorities cannot be set for the processes. No concept of priority, as all are given equal time. Round robin scheduling doesn't give special priority to more important tasks. Already explained. Decreases comprehension as it gives everyone equal timing and no different priorities also. Lower time quantum results in higher the context switching overhead in the system. This creates sometimes malfunctioning because of heavy load. Finding a correct time quantum is a quite difficult task in the system because when the number of processes is very large, it becomes hard for the system to get onto a perfect time slice to give each of the process. So now let's move on to the explanation and working part. Here I have 5 processes, namely P0, P1, P2, P3 and P4. Their arrival times and their burst time, and now we have to calculate their turnaround time and waiting time. I have taken the time slice 2. So now how we will solve it, as firstly the process P0 will execute, so its burst time is 5, but as the time slice is 2, so we cannot give it the whole 5, so we will give it 2. So now this 5 becomes 3. From 0 to 2 we have P0. Since P0 has now executed, so now it won't work, and P1 and P2 were also in line. P2 was also in line since its arrival time is 2 and 2 seconds have passed. So now P0 will be scheduled after P2. Now what happens? P1 will work. P1's burst time is 2, so 3 becomes 1 as 2 seconds are gone. So P1 will work till 4. Now 2 to 4. So now where will P1 go? Since the time is at 4 units, so P3 and P4 will also come here, and then the executed P1 will be scheduled here. Now what is in the line? P2. P2 has the requirement of 1 unit, so it will be totally executed till 5 P2. Now the process P2 is over. What happens now is P0 again comes into play. P0 has the requirement of 3 units, so now it will deduct 2 units and now it will remain 1 only. Then it will work up to 7 P0. It will get scheduled afterwards P1. Now P3 will work. P3 has the requirement of 2 units. We will give it 2 units and it will also end here till 9. P3 will work. Now what remains? P4. P4 has the requirement of 3 units. We'll give it 2 units. 1 will remain. P4 will work till 11. Now what comes? P4 is here. P1. P1 has the requirement of 1 unit. It will work up to 1. It will also end. Then P0. P0 will work up to 13. 13. So now P0 is also over. What comes next? P4 is the only remaining process and it requires only 1 unit of time. So P4 will execute till 14 and the whole process is complete. So what did our arrangement become? P0, then P1, then P2, then again P0. P3 and P4 didn't even happen, but P0 got repeated. Then again P3, P4, P1, P0 and P4, and the process is complete. Now what is turnaround time? Turnaround time is the time taken by the process to totally complete. So now in the case of P0, it started at 0 units and ended at 13 units. So its turnaround time will be 13 minus 0, that is 13 units. For P1, it started at 2 and ended at 12. So, and its arrival time is 12. So ending time minus arrival time is 12 minus 1 equal to 11 units, that is its turnaround time. Now for P2, P2 ended at 5 only. 5 minus arrival time is its turnaround time, that is 3 units. For P3, it ended at 9 and its arrival time is 3, so 9 minus 3 equals 6, 6 units is its turnaround time. P4 ended at 14 and its arrival time is 4, so 14 minus 4 equals 10 is its turnaround time. Now waiting time is the time for which the process had to wait for its total execution. Now turnaround time is 13, burst time is 5, waiting time is TAT minus BT. Now 13 minus 5 gives 8, 8 units is waiting time. 11 minus 3 gives 8, it's waiting time. 3 minus 1 gives 2, it's waiting time. 6 minus 2 gives 4, it's waiting time. And 10 minus 3 gives 7, it's waiting time. The waiting times are 8 seconds or 8 units, 8 units, 2 units, 4 units and 7 units respectively. So that's all for the execution in round robin algorithm. Thank you.
That's all for this presentation.